Hi, welcome to Shogini Systems. I'm Sri. This is another video where we are going to explain AI chatbot end to end. You will not find a similar video that walks through all different scenarios an AI chatbot can be deployed. I have split this video into several sections. Each will add extra sophistication. First, we will see a quick introduction to chatbot and see what advantages chatbots offer to an industry. Then we'll build a simple chatbot that works like ChatGPT, where the questions go to a large language model, and based on the knowledge that it has, it will respond back to you. So here the learning is how to embed a chat system on an existing website. Next, we'll add our own local knowledge. Like if your company has parking space or your phone numbers, your company employees, etc. So everything about your company, which will not be present in the large language model. So that can be added to the chat system and making your chat system more adapted to your own specific business. And then we will see how we can make that more optimized and we'll see what it means. So we are making our local knowledge accessible in a more efficient fashion. And finally, we'll see how that sophistication can be achieved using OpenAI's assistants, pre-created assistants, where you also feed the knowledge into it. So the work of adding the knowledge base, etc., is done by OpenAI itself. And finally, we will see how we can deploy such an application as a container, Docker container, so that if you need to scale, you can easily scale using Kubernetes, etc. So remember, there is no such video that is going to walk you through all the phases of a chatbot implementation. There are several ready-to-use chatbot service providers, but they all have subscriptions and they all have different ways of no-code automation. And when you implement such a system, you are actually tying yourself to their service. Here, you have the complete flexibility of adapting the chat system the way you want, because this is fully coded solution. And knowing this also will give you the power to understand ready-to-use chat systems. Let's get started. First, a very quick introduction to chatbot. Colorful multi-page websites are gone out of fashion. Its utility value has greatly diminished, especially after ChatGPT in November 2022. People don't have time to go through pages. They know that anything that they want can be queried. So you need to have an excellent querying mechanism on your website. And AI chatbot is such a querying system where if it's a dental clinic, if somebody wants to know if there is parking space, you can ask that question and specific answers pertaining to that business will come back to the user. So you can enhance the user experience. Another thing is for technical support, etc., you can have uniform support available to end user 24/7. Another thing is lead generation. So when a visitor comes to your website and begins interacting with the chat system, you can detect the intent and accordingly navigate the user and convert the user to a lead. So there are tremendous possibilities when you implement the chat system to your website. But in this video, our focus is to see the technology behind the chat system and how a chat system can be implemented. What are the different ways a coded chat system can be implemented? So first exercise is adding a chat system to an existing website. For this, we will use a sample single page website and we will add a chat system. We will see how it works first. On any website, if you add such a JavaScript code, just one line, this chat icon will come. Okay, so now the content of this is available for you to download in our community section. Please join our free community. Okay, so this chat is a JavaScript which you can get it done through ChatGPT. We are not going into that chat system because that is just the interfacing. We are only learning the technology behind getting the knowledge displayed back to the user. So let's look at the code. Before that, let's see how it works. Let's ask what is 2 plus 2. Okay, so it's able to answer what is your phone number. See, it's not able to get the phone number because this chat system has no local knowledge, no knowledge about the business on which this chatbot is implemented. So what we're going to see is, we're going to see how that is done. So let's look at the code. So the top sections are straightforward Python import statements. What is interesting, we will see. So this code has got one main routing slash simply deliver. Anytime we browse the root of this application, it will deliver the sample.html. So anytime we browse this chat, this function gets called. Okay, so that function is the easiest OpenAI call. So this works just like ChatGPT. That is, so here we are getting the message or the query from the user, and we're checking if it is valid. Okay, and then we are calling the OpenAI. And we are using one of their latest models, GPT-4o mini. Okay, so that is cost effective. And we are just passing one message, you're a helpful assistant, and then the user prompt is passed. And here, this element of the response, we get the reply. That is it, as simple as this. And then we return a JSON response. So that is the first thing that we are doing. We are just creating a main.py with few lines, which will deliver the main web page and also deliver the chat endpoint used by the chat widget.js JavaScript file. Chat system has no local knowledge. So we are going to see how we can enhance this chat system by adding our local knowledge. Okay, next section, where we are going to add our local knowledge into the chat system so that the visitor can ask any question pertaining to that website or that company. So let's see how it works first. So here is the same website, and we have the chat system, upgraded chat system. And here let's ask, what is 2 plus 2? Okay, so it's able to answer intelligent questions now. Let's ask, what is your phone number? See, it has given the phone number. And let's ask, who is the founder? Okay, so that is me. So this chat system has the knowledge of the large language model, plus it has knowledge about the local business. So let's see how this is done. So coming back to our code, so we will go over the section that is important for us. So here we'll see this, we are loading the knowledge base into this variable. The knowledge base is in the form of a text file. Let me show that text file. So here is the knowledge base in a question and answer format. It can be in any format. Okay, so this is how we have made our knowledge base. And coming back to the code. So here we are loading the knowledge base into a variable. And next is nothing interesting. This is same as before. It's loading the sample web page. Then comes the knowledge addition part. So let's focus on that. Actually, this is a very small code. Only thing is, you see the difference here. See, in this section, RAG stands for Retrieval-Augmented Generation. So the augmented message, we are prefixing the user's query with the knowledge base. See this? The knowledge base contents come here, then we are putting user column, and then the query raised by the user. So the whole thing, the entire knowledge base goes to ChatGPT every time you ask a question. Do you see the disadvantage? The traffic, the communication, number of tokens, duration, everything is not optimal. And cost-wise, this is going to consume many more tokens. Rest is all same. So you can see how easily we can inject knowledge by way of enhancing the prompting, by reading a local file and prefixing the question with the local file. Let's move on. Next, what we're going to see is we are going to optimize this local knowledge addition. We'll use embeddings. Okay, first let's see it's working. So here is the chat icon 2 + 2. Okay. What is your phone number? Okay, perfect. What is your company name? Do you see the performance difference? The response is coming much, much faster, isn't it? And local knowledge is present as well. So we will see how this is done. So let's look at the code. We are only looking at the important part which is not easily understood. We are using a sentence transformer. And here, do you see this? See this? Load and chunk the knowledge. So what it does is, it is going to split our knowledge base into smaller units. See, let's look at our knowledge base. See, this is the knowledge base. What it's going to do is, it is going to convert this into different chunks. And those chunks are overlapping chunks. Okay, so like this, it is going to split your knowledge into smaller units called chunks. And these chunks will have a unique vector. Okay, so let's come back to our code. So here, it is converting it into chunks, and then it is converting those chunks into embeddings. Embeddings are the numerical representation of those chunks. The numerical representation is like a coordinate which represents the meaning of the chunk in the multidimensional space. Okay, so that is all we need to know. And here it uses a mechanism to take your user's query. So here your user query is passed to this function. And the query also will be converted into an embedding, which is a vector. Then it will find the closest matching chunks from our knowledge base embedding. Okay, so that is what is happening here. So essentially what we are doing is, we are asking a question. That question will be converted into a vector, multi-coordinate vector, essentially comma-separated collection of numbers. And we have already converted our knowledge base into embedding. Then it uses a logic to see the user's question is closest to which embedding. For example, if user is asking, do you have parking? And then it will search the database, search the embedding vector store to find out all the contextual sentences which are pertaining to parking. So the exact word parking need not be there. You're getting it? So that is what this does. So all these extra thing that you need to do to get that relevant chunks. And why are we doing this? Because our previous system also was working. The advantage is here, if your knowledge base is 10 megabytes, you can, in this system, you're only going to send few kilobytes of matching embeddings from the knowledge. Got it? So that way you can reduce the number of tokens and of course improve the performance, overall performance. That is it. Okay? The rest is all same. Now let's look at the chat endpoint function. So here the user message comes, the query comes. Here we are calling the function to get relevant chunks from the database. And the augmented message, see here, it is adding relevant chunks to the user message. Remember earlier, we were adding the entire knowledge with the user message. Here we are only adding the relevant chunks. That is the main difference. So that is the difference in this way of implementing a chat system. Okay, welcome to the final, most sophisticated chat system. And let's see it's working first. Say 2 plus 2. See, it is behaving differently. Do you see this? It's saying, I can help you with that. Just to confirm, are you looking for 2 plus 2 within the uploaded files? I can say no. Listen, if you have any question here. So here, it is limiting the response. What is 2? It is limiting the response to the knowledge base. See here, it's saying it can't provide 2 plus 2 based on the uploaded file. So here we are restricting the chat system to answer only pertaining to the knowledge. We can do this in our previous cases as well. But I will show you how this is done. Okay? Now let's ask who is 3. Okay, so here it says, this is me. So here, it's able to answer based on the question. Now, what is the difference? That's what we're going to see. Before we see that, I want to show you this screen. This is the OpenAI's paid version where you have a mechanism called Assistant. Assistant is an object that you can create in OpenAI where you can also upload your knowledge. So that takes away the trouble of you converting your knowledge base into chunks and making it into embeddings, and then querying the user input to find the matching embeddings, etc. All those things we don't need to worry about. So here, this is the name of the assistant. Here is saying, here, I'm here to provide concise, accurate answers. I will match the responses to the uploaded Shogini file. So if you add this sentence to our previous chat systems also, it will ensure that it's not going to give general answers. And we're choosing the model. There are different models that you can pick. This is a cost-effective one. Then file search is enabled, and here we have uploaded our knowledge base. See here, this txt file is the knowledge that we have uploaded to this assistant. Okay, so, and this is a playground where you can test your assistant. 2 plus 2. See, it's saying, just to confirm that, so response is similar to what we got. Say, who is 3? See, it's running retrieval and see, this is about me. So now we will see how such a system can be integrated easily into a chat bot. Remember, you will not find similar video covering all these aspects in this fashion. So let's come back to the code, and we will focus on the chat endpoint like before. Now here, what is this? They are collecting the user query. Okay, so first we are creating a thread. A thread is like a message history, your questions and answers. Then we are creating a message by attaching the thread ID and the current user's message in this fashion. Okay, all these are available in their API documentation, but only the problem is seeing a working code will give you the power to be able to do it. Okay, so then we are going to run the thread. Okay, so here, do you see this? We are using our assistant ID. So if you look here, we have the assistant ID that we have created. So that assistant ID is what we are using here. So the thread plus message reaches the assistant here. Okay, and it begins executing. But now comes the problem. You will not get the answer immediately. You will need to have a kind of indefinite loop waiting for the answer. So that is what we are doing here. So here we are looping. Here we are retrieving the status. And then if it is complete, we get the message and come out of the loop. Okay, but if it is queued or in progress, we continue the loop. And if it is not in progress and not completed or not queued, we will terminate the operation saying that it has failed. Clear? So this part is clear. That is all. We don't need to do the chunking. We don't need to do the embedding. We don't need to do the matching. Everything is done by the assistant. So that is the beauty of this mechanism. And I request all of you to join our community where you get access to the code that we are demonstrating, including any documentation that you need to implement those codes. Okay, and please like, share, and subscribe so that more and more people will get such videos, and also our videos will get promoted, and it will encourage us to make more and more such videos and share with the community. Give us your valuable suggestions. Finally, we'll see what is the best way to deploy this as a production application. My suggestion is use Docker, containerize the application, and then deploy it so that you can use Kubernetes to scale the application depending on the use. It's very easy these days. I started using Docker some 7 years ago, and 2018, I have written a book on Docker as well. So in order to containerize the application, all you need is a Docker file that contains these lines. See this? This Docker file is a template to create a Docker image. And then what we need to do is we need to be in the folder Docker file. So we have a Docker file here. Docker build -t and give it a name. My chatbot. Okay. And full stop, which is the build context. When you run this command, it will create a Docker image in this local system, in the server. This will take time. This will take about 5 minutes because it is loading all the embeddings, etc. that we are using. Okay, so let's look at the images. See here, newly we have my chat image available. So now how do we run it? Docker run -d to run in the background, -p to map any port that you want, 80, say 89, colon, whatever port the application is listening, and then my chatbot. That is all. You have containerized the application, and you have created a Docker image first, and then we launched a container based on this. So if you have any question on how to containerize an application, how to deploy, all your questions you can raise through our community section. You can also book for one-to-one consultancy with us. Okay, so that completes the entire journey of building different types of chatbots and deploying it. See you again in another video. Bye-bye. Please remember to like, share, and subscribe. And also don't forget to join our community. Please join our community section. It is free. Once you join, you will get access to our videos and all the resources that are associated with the video. So that you have one place where you can get the video as well as the documentation and all the other resources that you may need for the video. These are all our videos which are very useful for your automation journey. So please join our community. Let's learn together.